Hi, I'm Andrew. Today I'm going to show you a product called Armaflex and how to internally line ductwork using it. You're probably familiar with this. This is the same material that we use to insulate refrigerant lines and stuff like that. It's a closed cell product. Does really good against moisture and other things like that. And I'm just going to go through best application methods, when to use it, when not to use it, and how to use it properly. Right here I've got regular R8 fiberglass duct wrap. This is the most standard insulation we use in our industry. But there's certain applications where Armaflex may fit better. I want to note that there's not one better product than the other. It's more or less what product fits the application better. For instance, fiberglass duct wrap has a really good high R value, whereas Armaflex, it has a good R value, but this is only like an R4. Also, cost with fiberglass is going to be much cheaper than the cost of Armaflex. But on the other side, Armaflex does so much better on moisture resistance than fiberglass. If this gets wet, it still retains its R value, whereas when fiberglass gets wet, its R value goes down and the whole duct system will start to sweat, stuff of that nature. So, you know, there's a number of factors that will force you into making a decision over one product over another. The applications we're using Armaflex on are most of the time web trusses. We like to line the inside of our ductwork because it is so difficult to insulate and do strip outs on a duct system when it's already in a web truss. So we'll line the duct and put it into a web truss, and it's much more durable. All your insulation seams are already covered when you fit it together. Normally, the houses I'm doing nowadays are insulated with closed cell insulation, and every part of the house that is inside that thermal envelope is considered indirect conditioned space. And try not to get all stuck on codes and tables here, but ASRAE outlines a lot about where and when you can use certain R values of insulation. And ASRAE table 6.8.2, I believe, will outline what type of insulation you can use and what R value per what climate zone you live in. So these are the tools that you're going to need to line something with Armaflex, whether it be rectangular duct, round pipe, or round pipe elbows. I'm going to do this video using this machine here instead. But just know that this process is simply like it is with laying out sheet metal. You basically lay your your ruler down, you give yourself a mark, and you give yourself a mark and you draw a line, you cut it. You want to use very sharp knives, and I want to mention that normally when your cuts start being jagged, it's normally the glue that's getting on the blade rather than the blade being dull. But both of those things you need to pay attention to. Is your knife sharp and is your knife clean? So now I'm going to start the process of showing you how to do round pipe. And what I want to mention about Armaflex before we even get far into this is a very tedious product and it is not forgiving. With fiberglass, if you tear the insulation or you mess up a seam or something, you simply put a piece of duct tape over it, you put some mastic over it, nobody knows the difference. It's done, it's fixed. With Armaflex, if you make a mistake, you're normally throwing this material into the trash. It's done for. And it's critical that you get it right, because when you're internally lining, once you snap this stuff together and you hook up your duct system, you can't tell if you have a defect. Like, it just lives there, it exists. That's another reason I don't like this material outside of conditioned space unless I've got it externally lined. You know, if I did this externally lined, I can confirm that all my seams are together tight and all that good stuff. Now, we use a process and we're real careful, and I'm pretty confident that most of this stuff is going together right. I'm just saying that if it didn't go together just perfectly, since we're in conditioned space, the issues coming from that wouldn't be that bad. So that said, we've got our Armaflex that starts right at the edge of this female pipe seam here. And then over here, we actually stop a little bit short here. And I'll get more into exactly where this stops at when I'm showing you how to insulate this piece of duct. But when this is together, this is putting a lot of pressure in between these two parts here. So it actually creates a good seal here, but also it's fully insulated all the way down. It's continuous. On our male crimp side, we run all the way to the edge here. It's running tight to the edge of this pipe. So there is a male and a female when it comes to insulating with Armaflex. So this is our male side, and as you can see here, this is our female side, you know, with no insulation on it. When we connect the two together, we're gonna have a tight joint with our insulation right here. So we're doing round pipe. We need to know the diameter of the pipe times pi. That tells us the total length of our insulation. And then we actually go a little bit tighter. We've come up with standards, and I've posted those standards right here for quick reference. I'll also throw them up on the screen here, but basically that is the size you will need for each diameter pipe up to 16 inch. You get above 16 inch, start calculating times 3.14 and test your fit before you go and mass produce it. Anyways, we're doing 12-inch pipe. That's what I'm going to line today. 12-inch pipe requires 38 inches of total width. And if we cut our insulation for the length of the pipe to be 58.5, that leaves us with 1.5 inches female side on that pipe. That allows us the clearance for the male side of the pipe to slide into that other duct. Let's go ahead and get started on this. I've got a 10-knocker TK5 here that we've heavily modified. This table here is actually made for regular fiberglass duct liner. We wanted to find a way to increase production a little bit. We got sick of having to mark everything out. This has worked great for us. We built this table here and we embedded these rulers. We routed out the edges and embedded them. We also cut the rulers to where the dimension starts is the actual cut. It equates to where it's going to actually be cut. So now that this is set up, all I have to do is simply unroll this and slide this bar here, and I'm cutting my insulation. It works out great. So I'm going to start by rolling this out to 58.5. This blade here has already been set to 38 inches, which is the diameter of the 12-inch pipe, plus a little bit more. So to do that, I've got my roll of Armaflex here. This is 1/2 inch self-adhering Armaflex. I'm not pulling off the roll. I'm actually unrolling it a little bit and letting that roll drop onto the floor. That way I don't have the tension of the roll itself when I'm actually going to cut this. Once I get that going, I just simply take this here and I just start rolling this right here. And what I'm doing is I'm using this hand here to put a little bit of tension on this piece of Armaflex, and there's actually a ledge right here that I'm keeping this insulation tight against. If I just simply started rolling this would actually, it would walk a little way this way and that way, and this blade would be cut in an uneven line, and we'd end up with a bad product in the end. So now I'm gonna start unrolling this, and when I start unrolling this, it's gonna cut my Armaflex right there at 38. I gotta be real careful to keep this edge of the insulation on this guide here and keep it square while it's running down the table. Now I got it right to about 58 and a half now. I'm gonna check to make sure this side is square. It's pretty close. And I'm gonna go ahead and cut it. 58.5 inches this way, 38 inches this way. Now what I'm gonna do, I'm gonna flip it upside down. I'm gonna cut a little bit of this backing here. I'm not cutting through the Armaflex. I'm just giving myself a starting lip for when we're insulating this round duct, and you'll see the benefit here in a second. But I'm just gonna come over here. I'm simply taking a razor blade in hand. I don't use a razor knife here. I literally just take the blade, and it works great. And I'm just cutting into the backing just a little bit, the whole length. And now, you gotta be careful not to go too deep and cut into the Armaflex here. It just makes it a little bit more difficult later. I'm now gonna peel or get the backing started right at this edge. I'm also gonna get the backing started right here, because once this is hooked up to the pipe, it's gonna be hard for me to get my hand in here to start this. It makes it much easier. It's even a fight to do right now. But if it was on the pipe, it would be much more difficult. So we're gonna go ahead and start a tab here. And I'm gonna go ahead and grab myself a piece of pipe. So I'm taking my piece of pipe here, and with the crimp side going this way, it's normally how I insulate, is my crimp side is to my left. I'm gonna put my insulation in my duct like this. Now, I'm gonna turn this around just so that you can see what's going on, but normally I just go ahead and start insulating it. So we're gonna start right at this corner here. I'm gonna get my insulation square. And what I'm trying to do is I actually want to stick this flush right here, but I want it a little bit over this lip here. Probably, I'm going to say a half a square. If you look at the insulation, there's little squares in it. We normally try to get about a half a square, which I think is about like a 1/4 inch, maybe a little less. But I'm going to start with this little corner here, and I'm simply going to stick that right there on that edge. And have a little bit exposed here. And I'm gonna start working my way down, keeping this this gap right here, keeping the little, about a 1/4 inch of squares up. And I'm gonna work my way all the way down the pipe. Now that I've got that strip down, I'm actually going to fold this down on itself here. As you can see there, that glue actually tucked into itself. It's kind of like nice and flush here now, but it's got some tension coming off. So I'm then going to come back to this lip we started over here and start peeling this back. And this first piece is a little tough. I'm going to come here and go about 8 inches at a time. And I'm going to take my time laying this beginning section flush. But once you get the beginning down, you can just simply push that the rest of the way over. Now that I've got that down, I got both sides of this backing started. I come up to one side, go like that, come up to the back side, go like that, then come to the middle, go like that. We're going to line this up with our crimp here. Get that stuck nice and clean there. Carry it down. We're just going to continue doing that over and over again until we're done. We have about 10 inches left. We're going to go ahead and peel this whole vapor barrier off. In this last section, we're actually going to have to line up under this lip of this male pipe seam here. So we're trying to get it lined up right there. This material has so much flex in it. So even though we measured it exactly 38, through the process of sticking this, it could have stretched or compressed a little bit. And this is where we have to make up that either compression or what is stretched. So we have to be critical to make up, to get this to land right here at the end. This is a difficult step, but you get it down after practice. I'm going to be careful not to let this stick to this pipe because it's not forgiving. As soon as it sticks, it is stuck. So I've got all my backing off. I'm going to come to this crimp side and I'm following the pipe down. I'm going to get it lined up right under that lip there. And then I'm going to keep it going here as I walk down this edge. Now, I got to mention air bubbles. You notice when I was doing this, I was always pushing this way. I was doing that to not push air bubbles into the center of the duct. Really, if there was some, this stuff has so much good adhesive on it that would probably not have a problem, but we try to avoid it. So I'm going to go ahead and press the last bit of air bubbles out from that last section I laid down. And that's an insulated piece of round duct, but this is really difficult to snap together. So I'm gonna show you a method we use to get this to close the seam on this. So now we're gonna snap this pipe together, but anybody who's snapped pipe together know that it can be difficult, especially if you're new to this. Another layer of difficulty is that manufacturers are no longer putting the button punches into this metal. So when it locks, it doesn't lock like it used to. There used to be a button punch in here, and this lip would catch that button punch and it wouldn't come out. So we don't have that, but then also on top of it, we've got this piece of Armaflex here that's gonna be fighting against this piece of Armaflex, and we want those two to have a lot of pressure against each other. So if this is difficult, that's good. Of course, if you overline it, it's gonna be impossible. So we want it to be difficult. We don't want it to be impossible. We've come up with a method here that'll assist in helping to snap this pipe together. And basically we start on one side. We're gonna start on the crimp side here, and we're gonna go ahead and get a little bit of this in. We're gonna make sure that we're lined up nice here. And we're gonna get as much of this pipe in as we can. And we're gonna hold it still, and we're gonna pop a screw in. Let me readjust my hand here. Pop a screw in about 2 inches back. The reason I did 2 inches back is so that when this goes into the female side, this screw head doesn't hit the other pipe that's intersecting. It'll make it impossible to put the pipe on. Another thing I did here is I am facing the crimp and I'm screwing on the right side of my seam. So when you look at that seam, you're wanting to screw down through the male into the female lip that comes under it. If you look at the pipe, you'll understand what I'm saying. So I'm gonna do the same thing on the other side here. So I'm still not snapped together. As you can see, I got this one side screwed, but that's holding everything together. It's gonna allow us to work with the smaller sections at a time. So I'm gonna get a screw out here. I'm gonna get this female edge in as far as I can. So I'm in pretty good here. Pop a screw 2 inches back. Now because I'm facing the female side, I went to the left side. So really, if you just look at your seam before you start, you see that female lip there. You want to be screwing down into that female lip. So now that I've got that, spin it around again. Now I can fight for the middle here. And basically, I'm going to go ahead and load me a screw up. I'm going to start right here, and I'm just going to work this pipe down. And it is difficult. It is a fight. You get better at it. So if this had button punches in it, when I got that center in, you would have heard a pop noise, and this would have been locked in, it would never come out. But because there's no button punches on this pipe, you have to use a screw to hold it in. And I also recommend in this application that we add more screws. So I'm gonna put a screw here, and I'm gonna put one more screw in between this other row of screws here. On top of that, I'm gonna put hard cast 1402 mastic tape over this, which is a real good adhesive. It'll also help that hold and that seal a lot better. So the last and probably most important step in this process is the inspection process. You can't just assume that this was done right. You have to inspect every single piece. Right here, I'm gonna start with inspecting that this is flush with the edge of my crimp here. I'm gonna look down here. I'm gonna make sure that my seam here is tight. And then I'm also gonna take this fitting, I'm gonna flip it around. And I'm gonna confirm that this is about 1.5 inches from the edge here. Now, is there a way to recover if these couple of items aren't where they're supposed to be? And the answer is kind of no. If this was back a little bit further, I could actually trim up this duct, which would allow my male to go in further. So that would be one way to recover there, and that's kind of okay. Thing is you now have like a 4 foot, 10.5 piece of duct instead of a 5 footer. If the mechanic doesn't know that and he lays out his job, he's gonna be 1.5 inches short. Now, in heat and air, that 1.5 inches normally doesn't matter. What I've also seen people do, and I wanna mention it's a no-no, simply take some foam tape like this. And I mean, it kind of makes sense when you think about it, but then there's one part of this that doesn't work. If you took this and stuck this over the seam like that, Here's the problem with it. It doesn't really stick. So this is going to end up in your return duct eventually. So that's a no-no. The only way you could actually do that and get away with it is if you use something like Armaflex's 520 adhesive. You got to know how to use this product properly. This is applied like a contact cement. It's not like glue where you put glue on one side and you stick it. It doesn't work like that. You put a thin layer of glue over one side of Armaflex. You put a thin layer of glue on the other piece of Armaflex that you're sticking to. You wait about 10-15 minutes until it's tacky to the touch, and then you stick the two together. When they stick, they're stuck. It's like contact cement. It's done. We try to avoid this. We try to buy all of our products with the sticky backing on it. This glue is you got to have good ventilation to use it. It adds another layer of things that can go wrong. Nothing wrong with it if it's done right. We just find this method to be easier. But really, I think the right way of doing this is if you're short on your seam here, this goes in the garbage and you start over and you do it right. We showed you how to insulate round pipe, and now I'm going to show you rectangular duct. This is actually a little bit easier than round pipe, but it still is critical. It's tedious, and there's some things that you need to know about to be able to do it right. There is a male and a female on rectangular duct as well, and there's a lip we actually leave on for the S-lock side. So the first thing we start with is cutting our pattern. I've already cut my pattern here. This piece of duct, this is 12 by 10 duct. It's actually 47.5 long this way because we cut it with a plasma table. If you would have just laid it out with regular metal, this would actually be a true 48 inches, but because we use our plasma table, we lose a little bit on the edges. So this piece is 47.5 wide. We cut our pattern an inch shorter to allow for our female side here, which is going to get S-lock, and the male side of the next section of duct is going to come into this. So this female side here is going to be bare. So when this lays out, it's going to be an inch short here, but it's going to come all the way to the edge here. This will make up our male. This will make up our female. Before we start lining this though, we're going to flip this around and we're going to cut a lip on our sticky back that's going to remain. We'll remove this later on the field. We're going to cut a lip right here and just in our sticky back, and all we need it to do is exceed 1 inch. It doesn't need to be any longer than 1 inch, but we want to make sure we clear that. So if we go a little bit further, we're okay. So I'm going to eye like 1.25 inches. Get this started here. And I'm not cutting very deep. I'm barely cutting I'm just cutting just the sticky back here. And I found that it's easier just to use a razor blade than an actual razor knife. And just come down here the whole length. And score your sticky back. Now that that's done, we're going to flip our insulation back. And we're going to start from this corner here. One more thing I want to discuss before we go any further. The female side of my seam is facing me. This is the female snap block portion. There's my male snap block. I am designating this right side as my male. The reason I bring this up is the next piece of metal I line, I need to keep my male going the same way. If I get my next piece of duct and I've got my snap block on this side and I make this my male side, when these two go together on the field, the seam's not going to line up. So it's important that whatever direction you start your male going on, you continue that direction. So my standard is when you're facing the female edge, your male seam is on your right hand. So I'm going to go back to that right here. So females, I'm against my female snap block seam. Right hand is my male. That said, I'm going to start on this corner here, and I'm going to keep myself 1 inch in. There's my female. There's two ways we can go about doing this. I'm going to show you the, let's call it the pro method, because the method I'm going to show you, if you make an error, you're screwed, but it is faster. So I'm going to show you the pro method. I will discuss the method that you can use if you haven't gotten really good at this. And that method is you can actually cut this pattern a little bit longer, maybe 1/2 inch, 1 inch longer. And you could start at your male seam, insulate this all the way down to here, and when you're done, flip it over and cut your excess off of this edge. I don't like that method because it's more work. It's one more step. It's just more time, and you just need to perfect the actual way of doing it. But if you're working with somebody who just can't get it right, you can resort to that for a little while they get a little bit better with the material. So I'm going to start with female edge facing me, males on the right. I know I keep saying that, but it's important. I'm going to start at this edge right here. Female is my corner, and I'm going to peel. I'm going to start this little edge right here with my sticky back, and I'm going to be flush right here on my female seam, 1 inch back on my female seam where the pipe connects. I'll start right at this corner, and I'm just going to walk this down. I'm actually going to peel this sticky back the whole length. Now all I'm doing now is keeping it nice and flush on this female pipe seam. When I'm a little bit away, I'm going to make sure this is lined up, and I'm going to continue pressing this down. So now I've got a start point here. This edge here is stuck. I can just simply take this material, drop it right there. I'm going to pull all of this off. And if you look here, this lip is remaining for my S-lock to put on my duct later. So now I've got my Armaflex here. I'm going to be real careful not to stick this to the pipe, because once it sticks, it's stuck. And I'm going to come to my female edge, and I'm going to simply walk it down here, looking that I have 1 inch right here. And I'm going to do just like the round pipe. And now when I get to my last 10 or so inches, this is where the pro side of this comes in. And it's because this material is not it's flexible, it will flex. So you need to make sure it lines into this. So if it's long, you need to tuck it under. If it's short, you need to stretch your material a little bit. So I'm gonna come up this corner, and I'm actually short. So I'm pulling right here. So we've got this laid out. I'm just going to go ahead and do a quick, I'm going to rub the air out just to make sure we're good and we're tight here. And this stuff, it's a real good material. Once it sticks, it's there. So like I said, if you struggle with that seam and getting that lined up at the end, you could always work your way back like this and then flip this material upside down and cut along this female edge. But that's one more step. If you have a short piece, it might cause jagged lines. It's better to just do the other method and get good at it. So from here, this piece of duct is ready to be bent, and we're using 1/2 inch Armaflex here. 1/4 inch and 1/2 inch Armaflex can be broke after it's put on the metal. Anything thicker than that cannot be run through a brake. So if you're using 1 inch Armaflex, you have to switch to 1 inch Coil Flex. Coil Flex is a product that Armaflex sells that allows compression in a brake. When you get up to 2 inch or something, if you probably can't do internal lining anymore because you'd have to do it 4 pieces. That's normally where you'd go externally lined. If I was doing something with that high R value, but I wanted the acoustics, I'd probably line the duct with 1/4 inch Armaflex for the acoustics, and I would line the outside with 2 inch Armaflex for R value. But that's going to be a rare situation because the cost is just astronomical, and that's where fiberglass would come into play and work probably pretty well on that application. time for an AGL Mechanical exclusive tip here. I see a lot of people a lot of times with snap lock trying to connect this together. They will try to come to one side and the other, and they'll try to line it up, and they'll try to beat this together like that. They're making this way harder than it really needs to be. So snap lock and getting this seam made is actually really simple. If you start on one side, let's start on my right side, and you line up these two edges and get your corner in just like you would do with S-lock. You just get the corner in there. You got to make sure you're lined up, because once you start snapping, you're done. So that's how you start it with it. What I want to show you is if this male snap lock got kinked, like see right there, see that kink? And if you were trying to fit it together flat like I was just showing you, it'd be very difficult to get this kink to set into the seam. But if you understand how metal forms, if you held this down and lift this up, if you could see that kink right there, it just disappeared. See, there's the kink. I'm lifting up, it disappears. So by using that method, if I get this side in and it's in tight, I can then lift up right here. All my kinks are out, and I can now simply follow this duct down, and that kink that was there, it pulled it right out, pulled it right into my seam. There's nothing to it. I didn't have to beat the duct out of it, I just barely hit it, and it went right into place. I'm then gonna follow it up with a screw on each side. I'm going through my female seam into my male seam. I don't need one in the middle. As you can see, that holds together real good. The notches on that seam, that is button punch. That was what I was complaining about our round pipe not having. Because this section had the button punch on there, this is a good solid seam. It won't come loose. You're gonna slide a piece of S-lock here, right? And you're gonna put another piece of S-lock on the opposing side. And this is normally gonna happen on the field because, as I explained earlier, the mechanic might have a decision on where he wants this ear to be. And the reason he might have a specific spot he wants it is because this drive, when you connect another piece, it slides into this. So if I'm working in a web truss, I need to be able to slide up. And if this ear is on the opposing side, I couldn't get to that top piece to slide that in. So now this has S-lock and drive on it. We have our sticky back still on here. You now on the field, peel this off. You stick it to your S-lock, and you now have a completed piece. When you go to slide your drive on, it'll simply slide right over that sticky back part. Another part of this is if for any reason this sticky back didn't get peeled, it is on the male side, and it is going with the airstream. So I don't believe it would be the end of the world if this sticky back actually never got peeled off. It should be peeled off. It should get stuck to the S-lock. That's the right way of doing it. I'm just saying I wouldn't bust a piece of duct open if I thought to myself, maybe I didn't peel that sticky back off. I showed you how to line rectangular duct, and I showed you how to line round pipe duct, but I used a 10 knocker table, which is the table that cut the patterns for me, and I figured I should just touch on it real quick. When you go to lay this stuff out, all you simply need is a layout ruler, and you need something like a silver Sharpie so that you can see your marks on the insulation. So if I wanted to cut a piece 10 inches, I'm just simply gonna, just like you would lay out sheet metal, I'm gonna put a mark at 10 inches here, I'm gonna move it up, I'm gonna put a mark at 10 inches here, then I'm gonna turn my ruler 90 degrees, I'm gonna line up on these marks. There's no point in marking this now. I'm just simply gonna hold my ruler tight, and if this is a long cut, maybe I have somebody with me, they might hold the ruler at that side, and I'm gonna do one clean cut here. I'm gonna press hard to where I'm going through the Armaflex and through the backing, the sticky backing. I wanna try to do this in one cut. I don't wanna do multiple cuts because when I do, it's gonna fray the material. So I'm just gonna do one nice clean cut here. It comes out perfectly nice and clean here. If it didn't, your blade is either not sharp or it's dirty or gummed up with the sticky back adhesive. It'll get on your blade. You need to clean this with alcohol. Another thing I want to touch on is when do we use round pipe, when do we use rectangular duct? Well, that is all application based. A couple things that you just need to remember is round pipe, if you're making turns with it, it is very difficult to internally line round pipe elbows. We've made pattern sets here that give us templates. for lining round pipe elbows. Armaflex actually has these templates you can order from them, but they come in paper and that's hard to reuse. So if you're getting into a complex system that has a lot of turns in it, normally rectangular duct is actually easier from a lining perspective, whereas round pipe's a little bit more difficult. But if you have, just one section duct and you're making one turn, you can run round pipe all day long and you just have to deal with one 90-degree elbow. Another thing to keep in mind is when you're lining duct, there's area loss. So if I've got a 10-inch duct and I'm lining it with 1/2-inch material, that is now a 9-inch duct. With 1/2-inch material, this is a very small amount and almost don't even need to calculate it on the bigger duct sizes. But if you start getting into 1-inch coil flex or something like that, and you have a 10-inch duct that you've lined with 1-inch coil flex, that's now an 8-inch duct. So you need to account for that loss. Assembly line process can be used for lining ductwork, but because the material cost is so high, you absolutely need to check your pattern sizes, make sure they work out before you cut 10 patterns and then line 10 pieces of duct. But with everything in heat and air, assembly line process can be used to increase production and work smarter, not harder. You can cut 10 patterns at one time and then line 10 pieces of duct at one time. The time spent would you'd probably save 40% of your time if you do it this way. But if you have a screw up and you cut 10 patterns that are the wrong size, you've got a lot of loss of material. Before you stick this Armaflex onto your duct, you need to make sure that your duct is very clean and free of debris. Every once in a while, they'll ship this sheet metal with a mineral oil on it. And if that's the case, you need to take rubbing alcohol in a rag and scrub the duct. It doesn't show up that often. We normally don't need to rub it down with alcohol, but if it's got any kind of lubricant feel to it, you absolutely need to clean it with alcohol. Also, when you're lining this stuff, you're laying it on a table. If that table has metal shavings on it, or it's got something that can damage the duct, remember that you're lining the inside and the outside of your duct is going to be exposed. And even if drywall is going in, I think it makes sense to show off your work a little bit and try to have a quality product. So if there's marks on the outside and dents and scratches, the final product's just going to look poor. If you learned something in this video, hit the like and subscribe button. Leave a comment in the comment section if you have any questions. And remember, quality is your reputation.